What's going to happen? Well, I'm going to have to find 1 over f first. So what is that going to be? You're going to do 1.36 minus the index of refraction of air, 1, divided by the radius of curvature, 50. Okay? So what is that going to be? Equal to 0.0072. Okay? I don't really need the focal length here. All I need is 1 over f. But just for interest's sake, we can calculate the focal length. That's going to be 0.0072 to the power negative 1. 138.8 centimeters. Still not a strong lens. The focal length is too high, but it's much stronger than having it flat, right? So then you put that number 0.0072 here, 0.0072, 0.0072. Over here, you do the same thing that we just did a minute ago. You just do 1 over di, right? 1 over di is equal to 0.0072 minus 1.36 over 15. So you have 0.0072 minus 1.36 over 15. Then you have, it gives you negative 1 over di, negative 0.08346. And you invert that, you get a virtual image. di is equal to negative 11.98. So the image is going to be right here somewhere. It's going to bend outward, and form an image here, right? So you can see that in this case, the image is actually a little closer to the object. A minute ago, for the flat surface, the image was negative 11. So now it's negative 11.98, so that is actually closer to 15, right? Well, we can keep progressing like that, make it more curved, make it more curved, make it more curved. What if the focal length was, let's say, 10 centimeters, okay? Or 5 centimeters. That means very, very curved. If it's 5 centimeters, what does that do? Well, then that makes this, instead of 0.0072, it makes it 0.072. It makes the focal length 13.88 centimeters. Now much stronger, right? It's curved a lot. So then what does this do? This is 0.072. So over here we get 0.072. So now what happens? 0.072 minus 1.36 divided by 15. Now the di came out to be negative 53.57. Very interesting. What happened there? This one has a radius of curvature, so it looks something like this. If you close this in, this one is going to be 5 centimeters. So what's happening is the light rays are coming, okay, and what is happening to them? They are bending away from the normal. Light rays coming. It comes down here and it bends away from the normal. Now notice what happens. Since this is curved a lot, it actually looks like the object is farther away this time. Instead of coming up closer, the object's image is way, way farther. Over there, over there. It goes over there and forms an image somewhere back there. So it looks like as if the image is coming from way back. Okay? Now, there could be a possibility here where if I make the radius of curvature a lot, very, very small, what could happen? For example, if I make the radius of curvature 1 centimeter, what's going to happen? Well, I'm going to put here 1. What's going to be 1 over f? 1.36 minus 1, 0.36. And then what's going to be the focal point? The inverse of that, 2.77. So this time it's the strongest lens, very, very curved. Okay, very curved. Now, if I put that here, 0.36, what's going to happen? This one is going to be 0.36, and you're going to have 0.36 minus 1.36 divided by 15. This time it's gonna give you positive, right? So if you invert that, it's gonna give you 3.7. So it'd be positive 3.71. So what does the picture look like over there? Okay, approximate picture I'm gonna draw. So I'm gonna make the curvature really, really steep. Okay. So what's gonna happen? The light ray comes, and it looks like this. The light ray comes, it looks like this, the normal. It bends away from the normal. It bends away from the normal, and it forms an image right here, right? So if it's very, very curved, it forms an actual real image in air over here. If it's kind of slightly curved, all the way back there. Not curved at all, closer in. Okay? So you can see this equation can handle any kind of case. It could also handle this kind of cases. Maybe the curvature is inward. Okay? What's going to happen then? If the curvature of the surface is this way, what's the only thing that changes in our equations? Then the radius of curvature here, the r, becomes negative. That's it, right? The radius of curvature becomes negative. Everything else you do the same way. Which way is it going to tend to bend? It's going to come like this, okay? Bend away from the normal. So this is the normal angle, and this is going to be away, and then this one comes like this, away. So it's going to form an image here. This kind of curvature will tend to bring the image usually closer to the surface, and it will usually be inside of the medium, okay? So now you know how to handle these kinds of cases where you're going from one medium to another medium, okay? Thank you very much.